Hi, good morning, good afternoon, everyone. Costa Rica and Ireland, and if you've joined from anywhere else, good morning, afternoon, or evening. I'm very excited to talk to you today about this bio encounter with Ireland that we've set up. So this is an interesting opportunity between the Biomaterials Hub in Costa Rica and BiOrbic in Ireland, where we're hoping to incite collaborative opportunities through various tracks around the bioeconomy and biomaterials. Just some quick housekeeping before we get going. After the initial introduction sessions about BiOrbic and Biomaterials Hub, we're going to move into 3 simultaneous breakout rooms, which you'll have the ability to join once the breakout rooms are open. When you're there, I would request that you keep your mics off, and the speakers will start presenting and sharing. There'll be an opportunity for Q&A, so there'll be a 10-minute presentation per speaker, followed by a 5-minute Q&A for 4 speakers, and then we would reopen the main room so everyone can join back in. We'll have an open discussion, and then finally we'll close off our session. We'll have moderators from CINDE, so from the Biomaterials Hub, in each of the breakout rooms, and they will be recording the session, they'll be moderating the Q&A, and they will be doing the timekeeping. So with that said, I'd like to thank you all for joining. I hope we're going to have a very interesting and exciting morning/afternoon of discussions around these topics of bioplastics, biopackaging, bioprocessing, and algae and microalgae. So without further ado, I'd like to introduce myself and then introduce Biomaterials Hub to you all, and then we'll pass it on to Professor Connor, from the director of BiOrbic. So biomaterials in general is a very loosely defined term. The original definition was always around materials that are functional or functionalized for use within the body, whether they're ceramic implants, contact lenses, replacement heart valves. But now, as you know, the idea of bioeconomy is becoming a big role in global industries. We're modernizing our definition, and that's what we're going with. We're going with materials sourced from nature that can be applied to all industries. So it includes the original definition plus this additional definition of materials sourced from nature. And this could be packaging, it could be things for the automotive industry, for fashion, and that's what we're calling biomaterials within our scope. So the Biomaterials Hub is a project developed by IDB and executed by CINDE. IDB is the Inter-Americas Development Bank. They are the major funders and sponsors of this project. CINDE is also contributing financials to this project, and we are executing this under the scope of CINDE. CINDE is the Costa Rica Investment Promotion Agency. And for everyone outside Costa Rica, CINDE is the company responsible for bringing in a lot of foreign direct investments through all these large industries that set up operations in Costa Rica. And I think this is also very similar to Ireland. Back in the 90s, there was a lot of foreign direct investment into Ireland, into innovation, into research. And this is what we're hoping to replicate in Costa Rica. So our goal is to turn Costa Rica into a big hub for research, development, and innovation around the scope of biomaterials. And we're hoping to be that central nervous system between the different stakeholders, research institutes, entrepreneurs, having investors, industry, NGOs, rural areas as well, and different communities. And the way we're going to do this, and the way that we've done this in the last year and a bit, was building up these collaborations and connections with all of these different stakeholders, identify the needs, identify the opportunity areas within the country and the region, and build up awareness, build up collaborative links, provide support and services, and empower the different communities to look at biomaterials with the new lens, and of course incubate, accelerate new companies, and a very important one, considering Costa Rica's let's say value proposition, which is supporting biodiversity. Costa Rica has about 6% of the global biodiversity in such a small landmass, which means accessibility and logistics and R&D have a huge potential within this sector. So our key areas are biomedical materials. So as the original definition, basically materials used within the medical industry that are functional or functionalized for implants, surgical tools, artificial organs, tissue engineering. Also biosustainability, which is the whole aspect of circular bioeconomy and sustainable use of materials, ideally towards bio-based materials, and how we can use biomass, and especially because of Costa Rica's huge agricultural ecosystem, the ability to take that residual biomass for the use of different industries and applications. And of course, as mentioned, biodiversity. Costa Rica has a huge ecosystem, and right now it's being heavily preserved, but we need to learn, understand, and value this as a major commodity for the country and the region. So there's a lot of work and research going on into exploring the biodiversity in Costa Rica, and now we're trying to look at how we could understand the materialistic value, the functional value, and the application value from a medical and non-medical perspective. So we have 4 key action items and areas within the Biomaterials Hub. We're trying to build up product development and innovation capacity through training programs, mentoring services, inciting new startup development. We're also trying to foster new startups and support them throughout their stages of development, from pre-seed and ideation all the way to scale and growth. And we're trying to identify new opportunities to support them through local and international partnership, either from a commercialization perspective or an R&D perspective or industry linkages. Which brings us to point number 3, which is we're trying to build up the academic provisions to the industry needs and to drive more tech transfer. So we're working with the technology transfer offices, we're working with industry, trying to map out the technological capacities in the country and how we can build up the innovative ecosystem that Costa Rica has a potential to be. And lastly, increased translational R&D, both within the local ecosystem and the local research community, but also with events like this to create new collaborative opportunities with global R&D facilities and global industries as well. So a few of our activities that we've had over the last year and to come over this year. So we've had training programs for students and budding entrepreneurs who have ideas but don't know how to utilize it. We've also had innovation challenges around biomass valorization and waste valorization. We've created another encounter event in person where we've engaged with people from the industry, researchers, and we've tried to create new opportunity areas and identify linkages between the research of the academic system and the existing industry that's present in areas in Costa Rica. We've also accelerated startups through partnerships, through our Green Tech program, and we're also working with a few international partners to create a venture building program. So this year, we're also developing another innovation challenge focused around bio-based packaging. This is in a collaboration between SMEs that would solve the challenge for industries. We're also setting up an R&D-based bioventures call or grant, focusing on bio-based materials and innovative biomedical materials. We've got a flagship event from CINDE in June 2023. And we're going to be organizing the day 2 of this event, which is focused on biomaterials. And of course, we've done some other, let's say, not so interesting from an R&D perspective, but important for the entire regulatory framework and the ecosystem in general, is developing suitable IP policy that supports innovation, supports R&D collaboration. And we're also supporting some of the outcomes of the initial bioinnovation training program through a 2nd stage incubation phase. So we've done a lot this year and we have a lot more to do for the coming years. This is a pilot project, so we're hoping to see how this builds up and acts as that central nervous system within the biomaterials ecosystem in Costa Rica and the region. Now, I would like to pass this on to Professor Kevin O'Connor. And yeah, take it away. He's director of BiOrbic. So we're looking forward to your introduction.
Thanks very much. Thanks for the introduction as well, and the intro into your own hub, which is great, very interesting. I think there are many positive overlaps or possible overlaps. So I'm going to try and share my screen now. Have a look. This might take just a second. Can you see that?
Yes.
Great. So thanks very much for the opportunity to tell you a little bit about BiOrbic. So in the short presentation I have, I just want to give an introduction to BiOrbic and then talk about specific examples like Farm Zero C, but also then maybe just project examples of bioprocessing, biotechnology and biomaterials, just to give you a flavor so that you can see the potential collaboration points, and then just some conclusion. So BiOrbic was set up in 2017. We had been applying for maybe the best part of 2 years, or preparing the application and getting it ready for the funding agency, Science Foundation Ireland. But our vision is to be a leader in the bioeconomy research and helping Ireland in a just transition towards a sustainable society. So there's a lot in there. The just transition is not just for let's say it's for all of society. It's not for just some people. So we would look at farmers, for example. We also look at industry. We look at citizens, people who are maybe not directly working in the bioeconomy, but are impacted by the bioeconomy. So it's really through excellence in research that we want to achieve that, and working with industry and working with farmers and a variety of stakeholders. So we see that global challenges can be brought down actually to local challenges. You often see that the global challenges that we face can be addressed locally, and we want to be able to work again with stakeholders and then help to translate the research. Yeah, so we want to do fundamental research, but we want to do research that's also oriented towards specific challenges and apply our knowledge and apply the outcomes of the research. And as I've mentioned already, it's really about excellence in research. We want discovery, but we also want innovation, we want invention, and for that to be applied. And we find that collaboration is the best way to do that. Yeah, it's really important to be collaborative. It's not just scientists, it's also social scientists, it's political scientists, it's a variety of different actors within the research sphere that are really important actors, and then looking at other actors outside of research and looking at that locally, nationally, and internationally. We also really value training of our PhD students and our postdocs. So we want to create future leaders. We want to be able to provide them with the skills. Some of them are hard skills, some of them are soft skills. It's about also helping them to realize that engaging with the public, using public engagement, which isn't core to their research, but it's really important to inform their research. So it's about talking to school kids, it's about talking to politicians, it's about talking to farmers, it's about talking to industry. It is about going out there and talking about your science, but also engaging in discussion and dialogue. And we hope then that will result in engaging, as a result of engagement, inspiring and involving societal actors, public actors, to develop the bioeconomy, and again, to have that just transition. So like I said, collaboration is really important. We collaborate with a lot of research institutions within Ireland. You see there Teagasc, which is Agriculture and Food Development Authority, but we have lots of universities as well, and technical universities, as well as maybe more traditional universities. They're not just based in and around Dublin, but they're also in other parts of the country. And we have a lot of industry collaborators as well. A lot of them are based in Ireland, and a lot of them are based in rural Ireland, in the countryside, but we also have international collaborations as well. But I don't have time, I suppose, to go through all the international collaborations that we have as well. So like I mentioned in a previous slide, we see the global challenges as being locally relevant. So for example, greenhouse gas emissions, that's globally obviously a huge task, but Ireland also faces its own problems with greenhouse gas emissions, and I'll talk about that with respect to the agricultural sector. And there are key targets in Europe, there are key targets in Ireland about reducing our greenhouse gas emissions and ultimately achieving net zero by 2050. And really important contributors to greenhouse gas and contributors maybe to greenhouse gas reduction are the operational systems that exist within the bioeconomy. That's agriculture, that's forestry, that's the marine. And how do we are building programs, we're building projects, and we're operating projects at the moment, looking to reduce greenhouse gas emissions, looking to ensure that the operational systems are climate neutral. But we also recognize that society will produce waste, whether that's plastic waste, whether that's greenhouse gas emissions like CO2 as waste, whether it's food waste. And we would use the word unavoidable food waste. We don't want to promote food waste. We want to say if there are unavoidable food wastes, how can we actually use those resources and maximize their valorization? And another one, of course, is about nature and biodiversity. So biodiversity is actually impacted by the operational systems and by the waste we produce. And so it is important to understand that when we're going for climate neutrality, we also have to be nature positive, and the restoration of nature and the preservation of nature are really important. So in our program then, we have a number of platforms. So we have an overall ambition, and that's to support the just transition to a climate neutral circular bioeconomy. And there's a lot in there in that phrase, but we effectively have 5 platforms. And those platforms deal with different aspects of the bioeconomy. And within each platform, you have challenges. So we build teams around different challenges within a particular platform. So for example, in healthy ecosystems, we look at biodiversity. We might look at biodiversity in the marine environment, look at biodiversity in, sorry, I'm thinking of another example, in peatlands, because we have a lot of peatlands in Ireland. So there are 2 challenges that we're going after. And then we have the climate neutral operational systems, which I've mentioned. You have forestry, you have the marine, you have plant-based production, and you have animal-based production in agriculture. And then the waste that, like I've mentioned as well in the previous slide, you know, you have things like greenhouse gases like CO2. It's actually a very good resource to convert it into other things like chemicals. You can take food waste and convert those using, for example, anaerobic digestion. It can produce methane, but that's a relatively low value product as an energy source. But you can also produce things like fatty acids from anaerobic digestion. You can short circuit anaerobic digestion, and those fatty acids are of much higher value. And of course, plastic as well. We have projects on converting plastic into products of value. We also want to look at the system as a whole, the bioeconomy. What's really important here is that we don't want to replace a fossil linear economy with a bio-based linear economy. So we have to look at circularity, we look at the movement of resources, we look at the use of energy, and also apply data and understand data so that we can actually be smarter about how we design the bioeconomy and the circular bioeconomy. And finally, but not least, we also have a number of enabling actions. So the 4 platforms to the left will all have, like we're building, actually, we have phase 1 now at the moment of our funding, and we're going into phase 2. And we will have social scientists, we'll have people with life cycle analysis, we'll have people who are skilled in economics, for example, and they will work with each of the challenges and each of the platforms in order to help them to better understand how, 1, their research is impacting society, and 2, how we can translate and bring the key messages from that research towards politicians, towards civil servants, towards industry, towards society, and also it'll inform our educational program for our PhDs and our postdocs. And these challenges interlink within a platform and across platforms as well. So just give you an example with Farm Zero C, which is a project funded by Science Foundation Ireland, and it's about empowering farmers to make changes so that they can become climate neutral, but also delivering lasting impact. It's not just that the project, when it ends, would stop. We really want to enable and empower farmers to make changes and long-term changes. And we collaborate with industry on this. Carberry is a milk processor, and they have a farmer cooperative. They have 1,200 farmers in their cooperative, and they're trying to achieve this climate neutrality with their demonstration farm. So we started with a real commercial farm that they're using as their demonstrator, and we're working and collaborating with them to try and change the farm. So Ireland has a particular problem with greenhouse gas emissions because 33% of all of our emissions come from agriculture. So it's an area that we absolutely have to address. And we're testing various things like animal emissions and manure emissions. We're looking at the carbon sequestration capacity of grasslands, because we have a lot of grasslands to feed our cows. We're looking at how we can change from grasslands to other types of grasses, mixed species, multi-species, in order to try and make the grasslands more resilient. We're also looking at the renewable energy on the farm. We're looking at habitat mapping, so we understand the impact of farming on biodiversity. And we're looking at the extent of the habitats and the quality of the habitats. And then we do a comprehensive quantification of all of that, so that we have life cycle analysis of the data, but also building a business model then that is suitable for the types of farms that we have in Ireland. They're not large scale industrial farms, they're family owned farms, typically having maybe 100 cows, 120 cows, maybe 80 cows, something like this, in that kind of range. Then on other projects that we have as well, we work with the mushroom industry, for example, that want to actually produce bioactives. So we're trying to use fermentation, for example, biotechnology to grow the fungi, not as fruiting bodies, but actually as mycelia, and then extract the bioactives or dry down the powder to have a bioactive rich mycelium. And we also have projects on producing biodegradable plastics using bacteria. And I think you'll hear more about that in some of the breakout groups. We're in this particular example, we're showing you polyhydroxyalkanoate, which is PHA, made by bacteria. The bottom left there that you see is biodegradable plastic or PHA inside in these cells, an electron micrograph. And to the right here are just some of the pieces of PHA that we made in the lab. We also use synthetic biology so that we can generate and create different pathways, blocking different side pathways to try and increase product production. And we also work on a number of different projects where what we're trying to do is improve health, whether that's environmental health, animal health, human health, by using extracts, for example, from seaweeds, from algae, by producing some products using biotechnology, by altering the diets of animals like pigs in this example, by feeding them mushrooms or particular extracts of mushrooms, we can improve the health of the animal and reduce the dependency on antibiotics. And we're also involved in policy development, again, with our social scientists and a variety of different scientists in the centre. And we are influencing, I suppose, the direction in which policy for the bioeconomy is going. We organise Bioeconomy Ireland Week in collaboration with a wide number of stakeholders in order to spread the message about bioeconomy, but also to hear from people. We are chairing an advisory board for the National Bioeconomy Forum, which is founded by the government. We're informing Climate Action Plan that was out in 2019. We're collaborating with the European Commission on their mission areas. We're writing white papers, I suppose, for the Environmental Protection Agency and for the government on how we can fast track innovation in the bioeconomy. And we're also part of networks like the All Ireland Climate and Biodiversity Research Network, which is promoting collaboration on climate neutrality and on increasing biodiversity. And so in conclusion, I know that's a whirlwind tour, but effectively we are trying to address a wide variety of challenges. A lot of them are in and around climate and circularity, but they are locally relevant and as well as globally relevant. And we think and we know that partnership is absolutely critical to achieving our goals. So we collaborate nationally, locally, nationally, and internationally. And that's it. That's the whirlwind tour. I apologize it was so quick.
Thanks a lot. That was really insightful to really understand about BiOrbic, and I see a lot of synergies between at least BiOrbic and the potential that Costa Rica has as a country and the researchers and the research ecosystem that we have here. So without taking up any more time, I'd like to invite you all to join the breakout rooms. My colleague Jonathan will be setting that up right now. You'll have 3 breakout rooms: the bioprocessing, bioplastics, and the algae. And you'll be able to choose whichever one you want. We'll have 4 speakers for each one. I'd like to remind you that the speakers is going to be 10-minute speaking sessions, 10-minute presentations, followed by 5-minute Q&A. The moderators will be timekeeping, and you will be, well, at a 2-minute mark, you will be, let's say, reminded that your time is almost up, and then we can move on into the Q&A. So yes, very exciting time. I'm excited to hear the presentations, at least in the breakout room that I'm going to. I'll be moderating the bioprocessing breakout room, so if you please make your way to the different breakout rooms if you haven't already.
Thanks very much, Adim.
In the basement, we have a pilot plant. Sorry, we have a can reactors there. Also, we have extruder. We have a internal mixer. Beside all the other equipments. So what we do at Polyuna, because we belong to the School of Chemistry at the university, we have to teach. We teach several courses, but we have these polymer materials courses in charge. Also, we help students with their graduation projects. We have undergrad students, and also we have external relationships, especially with the industry, with the polymer industry, and of course with the knowledge universities and research centers, either national or international. In the case of research, because of this abundance of biomaterials in the country, we work with these 2 lines, with these bioresources from the land, agricultural, and from the ocean mainly. So we do, for example, composite materials, micromaterials, biomaterials, bioplastics, nano biomaterials, for example. Lately, maybe in the last 5 years, maybe we have done more work on this topic. Of course, as I told you, we started 40 years ago working with cellulose and lignin, but maybe nanocellulose we started maybe more recently, and obtaining in the form of fibers, whiskers, or films. Also, we combine these materials with, for example, a polymer matrix to make composites. Normally, or maybe we use these 3 sources, especially from pineapple, because Costa Rica now has a lot of area with these pineapple farms, very big farms, and we use the leaves from the pineapples to normally are just burned or just thrown into the river, and they have a lot of pollution. So this is the case of nanocellulose, and in the case of chitosan, also maybe we started a long time ago, but now we are doing more research, more use of this polymer. This is a modified polymer from the chitin, and normally we extract this material from the shrimp shells. We have a 1,000 liters tank reactor in the basement, which can process 300 kilograms shells per batch. Also, we can use the chitin just like that, or transform it into a chitosan by using another process. And more recently, also we started working on starch, especially from cassava, because we have a lot of this product from not that much of the pineapple, but normally the people have some waste material that they have to discard because they don't get the quality level. So they have this material that can be used into and convert into thermoplastic starch. Normally, they have this bitter cassava that has a lot of cyanide, and they use that for another industrial processes. That's the cassava that we use in the lab. So we combine, for example, this TPS with whiskers from nanocellulose. In this case, this is from pineapple. And also we added, for example, rosemary oil to get some antimicrobial activity. We can use also this material from the pineapple fibers, not as just the lone fiber, and combine into the TPS in another process. We use here a compressed molding machine, and to obtain some semi-rigid material. Sorry. So for as a perspective for the near future, of course, we have a lot of interests. We also will continue with this research that I mentioned before. But for example, just to mention some of them, for like continue with to start smart packaging, studying this smart packaging to get some functionality of these films that I show you. Also to go back to the lignin, because maybe at some time in the history of the lab we use this material more, but we would like to go back to the lignin aspect, and also do some biodegradation, especially because of this, for example, this bioeconomy and all this stuff that is going on. We would like to set up some more tests about this subject. So thank you so much, and I will be happy to answer any of your questions. Thank you.
Thank you so much, Dr. Jimenez, for this great talk. And please, if you have any answers, please raise your hand, or you can write it in the chat. Yes, Dr. Naranzik, please.
Thank you very much, Jonathan. Thank you, Guillermo, for your presentation. I was just wondering about your cellulose. So you're using pineapple directly and extracting cellulose from the pineapple leaves. Is that correct?
Yes, from the pineapple leaves. This is a process, a mechanical process, and then you combine with the chemical process to bleach, and then you get the cellulose and microcellulose.
And how difficult, or is it labor intensive process, and what kind of chemicals do you have to use? Because frequently when you look at the publications, bacterial nanocellulose is kind of pushed a little bit forward, I think, when you compare the two processes in terms of production, but also in terms of consistency of the material. What do you find with your process?
Sorry, I didn't hear the last part.
So how do you find your process in comparison to that, like bacterial nanocellulose production?
You mean bacterial?
Yeah.
Well, maybe some, I don't recall it now, but maybe some part or some point that we have this idea of this bacterial nanocellulose or cellulose. But of course, maybe we have been used this chemical procedure since a long time ago, and now we are trying to move to a more mild process by using temp oxidation and trying to get a longer fibers, and also to combine with this mechanical process using this grinder called Mazuco. But the bacterial, the bacterial cellulose, this is something that I don't remember we have, for example, done, but maybe thought about that. But I don't know if that answers your question.
Yes, thank you.
You're welcome.
Thank you, Dr. Naranzik. And please, Dr. Babu.
Hi, thank you for your presentation. So just I'm wondering, so how do you interact with the industry based on your current research in this space? Do you have much interactions with the industry to bring what are the technologies you are working, in this area?
Yes, that is hard because we have some, for example, collaboration or alliances, but normally it's hard with industry. Actually, when I have the opportunity to talk with some people from industry, sorry, I try to make to attract their attention to the point that we have a lot of resources that can be used, and especially for the people with in the pineapple industry, that they have a lot of materials, valuable materials that can be used. Maybe they can join and make a big industry of that, and to produce not nanocellulose, but because they're yielding, but for example, at least cellulose or lignocellulosic materials, or some lignocellulosic fibers that can be used. But sometimes that's hard to, at least in Costa Rica.
Means, what are the main roadblocks? It's cost, or what are the main problems with industry? Is it just because of the cost, or they don't want to try?
As maybe I'm talking about maybe some of them, not all of them, because also we have some relationship with maybe several companies that they are interested, and then the way we like to work in that with them is through students, because we tutor them, and they can make they make their graduate thesis on that project, and maybe they are hired. But normally there are small companies that are interested.
Okay, thank you.
You're welcome.
Thank you, Dr. Rubble, for your question. And let's continue with Mr. Douglas, please.
Yeah, just a quick question. I see in Costa Rica you have a large medical device export sector. So have you had any discussions with industry in Costa Rica that are interested maybe in the recycled or biodegradable plastics for their medical devices?
We have a relationship with this kind of industry, of course, especially because most of our students, many of them are when I finish here, they're going to the work with these companies. But maybe I have some colleagues here that they can maybe tell me if I am wrong. But around this bio degradable materials, we haven't had any contact, at least as I recall.
Okay. Thanks a million.
Thank you.
Thank you, Mr. Douglas. And Mr. Vargas, please.
Thank you very much, Guillermo. How are you? It's very, very interesting to hear about Polyuna so many years. I haven't heard about it because I've been in other things, but I wanted to know if you still keep the Japanese cooperation relationships with with investigators from Japan, for example, especially in the field of algae, green algae development, and in green algae, bioresources that are being used recently in making new products and new bioplastics. Or do you have any other related investigation that doesn't have to do with agriculture, but with marine bioresources? That's my question. Thank you very much.
Okay, well, I think there were many questions, but I think about the first one that I remember about the Japanese cooperation. Sadly, we haven't had no more collaboration. Maybe in the last 5 years, maybe before that we have something, but I think that's around the about the algae. Maybe in another schools, maybe in the biology school, they have more. They have more work on that, and maybe they have collaboration with the Japanese agencies. But as for in the case of Polyuna or our lab, we don't. As I told before, maybe we have these ideas somewhere some time ago, we mentioned sometimes we write proposals and maybe they don't get accepted. Maybe was one of the topics maybe we have had in mind. And maybe if you can repeat the last part.
Yeah, it's because I've heard that green algae has materials that can be used to make new bioplastics. And it is very well investigated. And for example, some Japanese companies and some researchers are working on that. And they have proved to be, for example, very, how do you say, very good for environmental from the behavioral point of view. And my question is if you've had some approach of some, how do you say, small tests or assays relating to the production of bioplastics from, for example, green algae or other marine bioresources. That would be my question.
Okay, no, sorry, we haven't had that at least to make tests, or maybe the ideas I told before, but no, we haven't done anything with these materials.
So thank you so much for your questions, and also thank you so much, Dr. Jimenez, for his presentation. Let's continue with the third presentation. It is in charge of Dr. Narancic from University College Dublin. The floor is yours, and we are excited to hear about your work, Dr. Narancic.
I'm here. Let me just share the screen with you. Okay, you should be able to see the screen now. Is that okay?
Yes.
Perfect. Okay, so my name is Tanya. I know that my last name is a mouthful, but it actually comes from naranja. So if you know that, maybe it may be easier to then pronounce it. So I am based in University College Dublin, and my research focus is on metabolic engineering of bacteria. Production of biopolymers is kind of collateral damage here, and I'll explain briefly. So my background essentially is my undergraduate diploma or graduation diploma is in molecular biology and physiology. And during my PhD, I worked on bioremediation essentially, and I was focusing on kind of trying to figure out how can we use bacteria to remove pollutants, and specifically I was focusing on mono and polyaromatic hydrocarbons. And then by chance, I came into contact with Kevin O'Connor, and then we looked, how can we not only remove these pollutants from the environment, but can we use them essentially to make something that's valuable? And that's how I got into biocatalysis, where I view microorganisms as a black box, and I like to tune that black box to be able to use something that normally they don't use, or use much better what they can use poorly, and to spit out something on the other end, which is of value to us. And how did that bring me to work in plastic field? So we obviously are trying to move away from take, make, dispose principle in plastics. And this is a report from from Plastics Europe, where we can see what is the vision for a circular plastics economy, where we use virgin feedstocks, we make certain materials. The European Commission's view is enlarged to reduce and reuse what we already make. But when we have to use virgin materials, yeah, we'll use them, we'll make something else that's useful for us. Then post-consumer, we will collect everything that's been used, and then we're going to sort and separate this waste. What majority should be sent towards recycling route, and what cannot be recycled will be either incinerated with energy recovery, or sent to landfill at the lowest possible extent. However, when we put some numbers to this issue, we see that this circular plan is not really working, because these are the numbers that refer to EU only. So on an annual level, we would produce about 56 million tons of virgin materials, so plastic on an annual level. On an annual level, only half of that will be collected. So half of it isn't accounted for. And when you think that packaging is the major destination for plastics, obviously there is a problem, because this packaging will be mostly single-use packaging. Of what is collected, 40% ends in incineration, which, yes, it is a way to kind of deal with plastic waste, but we lose valuable carbon. 25% of what's collected is being diverted into landfill, and only 32% actually sent for recycling, which is way below EU targets for recycling. But when you see of what is recycled or sent down recycling route, and actually returns back into being used in plastic materials, only 4 million tons of recyclate are being employed. And usually it goes towards products of a lower value. So if you start with a bottle, that might end in a carpet, for example. And again, it can only happen so many times before it will end down one of these routes. Chemical recycling is promising, because then you're breaking down polymer into monomer constituents, and then you can use these monomer constituents to build a bottle again, rather than your carpet. But again, it's not developed to the extent where we can use it. So what we have recognized as a big potential here is to use these materials that are coming from plastics and use them as a feedstock, and then produce something of higher value. So what we did as part of our EU-funded projects, P4SB and MixUp, P4SB ended a good while ago, MixUp is still ongoing. It's actually a sister project of BioICEP that Ramesh has mentioned. And if you want to see who are the partners and what we're trying to do, you can follow this link. What we did, we came up with a kind of two-stage bioprocess. In the first stage, we are using materials such as polyethylene terephthalate, which is enzymatically degraded into monomer constituents, which are ethylene glycol and terephthalic acid. And then we can directly use this hydrolysate. There is no need for any purification. We can use it as a feedstock to grow a bacterium called Pseudomonas umsongensis Geo16. It is important to remember that I'll be talking about Geo16. And this Geo16 can natively accumulate a polymer called polyhydroxyalkanoate. Kevin mentioned it, Ramesh mentioned it, but we also equip this organism by metabolic engineering with the ability to produce hydroxyalkoxyalkanoic acids, which were then used as monomers to produce novel biopolyurethanes. I will be focusing on polyhydroxyalkanoates here, because they're produced as storage molecules inside the bacterium. And Kevin already showed you this image. And you can see these big blobs inside the bacterium, and that's PHA. So these are bacterial polyesters that bacteria accumulate pretty much similarly to the way we accumulate glycogen or lipids. So it's a storage of energy and carbon. It is made of monomers that are called R3 hydroxyalkanoic acids. And this is, again, very important, because bacteria can accumulate different polymers made of these R3 hydroxyalkanoic acids. But if they have only a methyl group here, they're called short chain length PHAs. And this group can be changed to longer and longer chains. And with the increase in the chain length here, properties of PHA are changing. So you can see that when we have these short chain length PHAs, we can produce material that's quite brittle. And then with the increase in the chain length, we can produce material that kind of goes towards adhesive and more liquid elastomeric materials. So mechanical properties and physical properties are going to be determined by monomer composition. And why do I want to use Geo16 as a platform? Well, you can see here a diagram that represents metabolism and several of the kind of central metabolic pathways in Geo16. And when we feed substrates that are what we call carbon unrelated substrates, so that don't resemble these R3 hydroxyalkanoic monomers, such as glucose or terephthalic acid and ethylene glycol, then these are broken down into central metabolic pathways, and a critical intermediate that we call acetyl-CoA is being formed. And then this critical intermediate is being sent towards a pathway that's called de novo fatty acid synthesis, and you can produce medium chain length PHAs. If you use carbon-related substrates, such as fatty acids that can come from various plants, for example, you can then produce PHA via beta oxidation. And G16 is very interesting because in addition to these pathways to produce medium chain length PHA, it also contains a pathway to produce short chain length PHA. So you can imagine that we can use this microorganism as a platform to mix short chain length and medium chain length PHAs and create composites in vivo, essentially, and thereby change the mechanical properties of PHA. Now, what's very interesting is that PHA have regulatory roles, so it's not that easy to kind of just interrupt this natural flow of intermediates, but we are trying to address this within another EU project, which is called Uplift, and it actually, Uplift might be of interest to you even more because this project deals with sustainable plastics for food and drinks packaging industry. And within this project, what we're trying to do is essentially divert this carbon flow so we can direct how much of short chain length or how much of medium chain length monomers we can insert into the material. So even though they're all called PHAs, it's a family of polyesters, and you can see when we have more of short chain length, this is what the material looks like. And when you have more of medium chain length, then you get more kind of elastomeric material, as I said. So what we're trying to achieve here, obviously, to make tailor polyhydroxyl conates, both for functionality, as Ramesh mentioned, we need to engineer properties, mechanical and physical properties, if we want to use these polymers, for packaging. But packaging is not, let's say, main interest to me, even though I personally think that packaging using biodegradable polymers can be valuable. European Commission, again, is setting up targets to not use biodegradable polymers for packaging. But what we want to do is maybe focus more on applications where these plastics may unintentionally end in nature. So why is that? Ramesh again showed the study that we both were involved in. And if you look here just at the difference in degradation when we have polyhydroxybutyrate, which is part of short chain length, or medium chain length PHA, or a composite of the two, you see that the green lines represent PHB, and it performs much better in these unmanaged environments such as soil, fresh water, or marine. While polyhydroxyoctanoate, which is a representative of medium chain length PHAs, doesn't perform so well, particularly.
Dr. Narancic, 2 more minutes left.
Perfect, thank you. So what we believe is that by generating these composites, we can improve functionality, but we can also improve biodegradability. And finally, what we're interested in doing is also to scale up the production of these tailor-made PHAs, particularly by using industry residues or waste or lignocellulosic biomass. And I will thank you for your attention and invite you for questions.
Thank you so much for your time to share your work with us, Dr. Narancic. Let's continue with the question and answers. Please, if anyone has any answers, or please raise your hand or write it down in the chat, please. Yes, please, Dr. Sorry Jimenez.
Thank you. You just call me Guillermo. Thank you for your presentation, Dr. Narancic. I don't know if I pronounced well your.
Excellent.
Because I'm sticking with the naranjas. Or sorry. I normally wonder about the cost, because I don't know. I think I saw like a plastic bag made from, I think it was PHA. When you compare with this more, I think it's elastic, or I don't know if it was a copolymer. But I normally wonder about the price, the cost of these materials made from for example, this kind of procedures? I think it was bacteria.
Yeah, it's a great question, and it is the biggest impediment to kind of higher penetration of PHA into the market of plastic. So it is recognized that the feedstock cost contributes the most to the overall cost of production. And we have developed here in-house processes for high cell density cultivation of organisms at 100-liter level, using waste materials, including waste cooking oil. We have published on that several publications. Waste cooking oil is a great source of carbon-related substrates. So what you get is simultaneous growth and PHA accumulation, which does not happen when you're using carbon-unrelated substrates. The second issue is obviously you need a lot of water and energy to grow bacteria, but with process development, we can shorten the time required for the cultivation. We can grow them to high cell density, and then we need to extract PHA. Where, again, we have methods that are kind of suitable for this level up to 100 liters, but over 100 liters, there needs to be further development. I have heard last year at World Plastics Association meeting that, Danimer from the States is already selling crisps, bags of crisps. Bags are made of PHA, so obviously they have found a way to reduce the cost of downstream processing and production.
Okay, thank you so much.
Thank you.
Thank you, Mr. Guillermo. Any more questions? Okay.
Thank you.
Thank you so much, Dr. Narensek. Let's continue with the last presentation of this bioplastics and bio-based packaging session. And please receive the Dr. Batista from National Laboratory of High Technology of Costa Rica. Please, whenever you're ready, you can start, Dr. Batista, please.
Hi, everyone. I'm disconnecting my camera for the stability of the internet. Can you see?
Yes, we can.
Okay, good morning. First of all, I would like to thank you for the invitation. My name is Diego Batista Meneses, and today I'm going to talking about the scientific collaboration of Lanotech in the area of polymers and bioplastics. I'm a biologist and I have a master and doctoral degree in industrial biotechnology. I have some experience in bioremediation, bioprocess, microbiology, especially applied for enzymes production, lignocellulosic enzymes, in the extraction process of natural polymers like nanocellulose for produce biofilms in biomembranes. Currently, I'm a research in Lanotech. This is a national nanotechnology lab where I'm responsible for the material characterization lab. Lanotech is a lab that belongs to CINDE and was created by the initiative of CONARE. CONARE is a national council of rectors formed by the 5 public universities in Costa Rica, UCR, TEC, UNA, UNED, and UTN. Lanotech was founded in 2004 in the position of director, the PhD Jose Vega Valdrit. In general, the lab has a very good infrastructure and comprises in six areas: chemistry lab, microbiology, materials characterization, reactor plant, 3D print, and microscopy. The lab have many equipments like TEM, SEM, DSC, HPLC, DMTA, and others equipments for material characterizations. About the research areas, the lab presents research focused on 4 areas: biorefinery, especially agro-industrial biomass and circular economy, bioinspired in biological materials, micro and nanomaterials, and polymers. Within the research activities that we are developing, we can mention optimization of methods for the extraction of natural polymers from agro-industrial waste. The lab has very large experience in this area, especially for use agro-industrial biomass like pineapple peel, orange bagas, sugarcane bagas, and other. In this case, we have some works published in international journal like this, focused in production of biomembranes, reinforcement with nanocellulose extracted from orange bagas. Within this area, we have in this moment some works for the increase of drugs in membranes used for chronic heritage treatment. So interesting because is one area important in Costa Rica because the country expanded, especially in the biomedical area. Furthermore, synthesis of bioplastics using biomasses. This idea is in this project in this area is construct biofilms with antimicrobial activities from agro-industrial and shrimp waste, mix this to waste for products, bioplastics for packaged food. This is so important for Costa Rica in this moment because the country is staying in the transition stage for use only on bioplastics. This is, in this case, the lab put your interest for producing this type of materials. The production of bioplastics using BLA. In parallel to the synthesis of a bioprocess, we also developing researches on the processing and destination of bioplastics. In this case, it's optimization of the polymer composting using domestic and agro-industrial protocols, and to study and detection microplastics in the environment. We have some works in this area too, especially for produced bioplastics, but we started some works in the composting processes in detection of microplastics. Regarding future investigations, we have some approved projects, creation of institutional agreements in proposals. The first is like one collaboration with the university in Peru, focused in biosynthesis and functionalization of bioplastics for use in industry of berries. The project starting this year. In other hand, composting or degradation of polymers processing using physical, chemical, and biological methods this project is specifically is a project with UCR, is University of Costa Rica, for optimizate this process of composting and degradation of polymers using different conditions like pH or temperature. Furthermore, a study for the elaboration of biomembranes for more efficient biomedical applications. This point is super important because I can mention the increment of the biomedical industries in Costa Rica. In this case, so we have some works with 2 scholarships for created biomembranes using different medicines and pharmaceuticals for application in heritage treatment or other types of treatments. In the last evolution of diffusion of microplastics in the food chain by means of root and foliar systems of plants. This is interesting because we know the presence of microplastics in the human body, but it's more important understand they started the process in the food chain. In this case, we developing some research about composting plastics, and after applied these plastics in the with substrate in the plants for understand the process of diffusion these microplastics in the foliar and roof systems. This is our work group. Is formed with different professionals in chemistry and natural science, microscopy, nanotechnology, material engineers, biology, and other. Thank you so much for your time. Any questions? I'm here.
Thank you so much, Dr. Meneses, for your presentation and show us the work that you're doing in Nanotech. And if you have any questions, please raise your hands, or also you can write it down in the chat. Yeah, Dr. Narancic, please.
Thank you very much. Thank you for talk. I actually noticed now, and then I remember that I noticed that in Guillermo's presentation as well, your bioplastic has very nicely printed logos. How do you print on the plastic? And, you know, obviously if it can sustain plastics, and the properties are very interesting.
Okay, print, in this case, the print not necessary for construct bioplastics, but we have many jobs with PLA or synthesis of different bioplastics using PLA, a composite PLA, and chitosan and other polymers. In this case, applied the print for make an impression of different structures, not necessary for packaged food, but other material types.
Yeah, I was just wondering, you know, when you showed on the slide, you have
membrane. Okay,
yeah, and then you have like a colorful logo on it.
The color is because the material is starch. The material, this membrane is starch in this structure for is only starch in nanocellulose for the casting methods.
Okay, thank you.
You're welcome.
Thank you so much, Dr. Narancic. And Dr. Babu, please.
Hi, thanks for the presentation. Just a quick question on the membranes. So the membranes you showed there, have you using any particular application, or it's a demonstration? The membranes you have showed, I'm not sure, is that microporous or nanoporous membranes? What sort of porosity, and what sort of applications you are intended? Those sort of membranes coming from cellulose or other polymers.
About this time, especially for health application, biomedical applications, we started these investigations in, we need understand some points. In this case, we need to study more for application, but we focus especially in the process of construction, the biomembranes, but we need some fit for the process of application, because we don't apply this technology to. You understand?
Yeah.
I'm so sorry for my English because
I totally understood. No, as I said, one of my research areas is in membranes, and we look at the application of membranes for a medical device. Basically, if you know this lateral flow test kits, like a pregnancy test kit, or so the membranes are widely used, in this sort of applications. So just I want to understand, what sort of biomedical applications are you looking at? So for this sort of applications, you need a micro, symmetric membranes with a micron pore size, so that you can use like in a lateral flow applications. Okay, so that's the reason I was asking. And secondly, you showed your future projects. I think all those areas probably we are working at the moment, in a different projects actually. I'm not sure, what is collaboration opportunities to work together. I'm not sure, maybe we'll be exploring that maybe, maybe in the main room, but I think, there is a lot of synergies what we are doing here. So yeah, we should explore, is there any collaboration opportunities?
Okay, it's so interesting. We can continue the conversation with the email. We in this moment study. I can mention study the process of construction of membranes, but to process of diffusion, especially liberation of pharmacs in this process, adapted these different methods for them. Only this, but we can. You can continue the conversation in another time.
Sure. Thank you.
You're welcome.
Thank you so much, Dr. Babu, for your question. Any more questions? Okay, let's see. Yes, we don't have. If anyone has more questions in regards to the previous presentations, we have some extra time to discuss, and also if you have some doubts or questions, also we can share it in this space. Okay, let's see that no one has more questions. Talking about the last topic or the last thing that Dr. Babu says about collaborations, I would like to start or to ask you if you see any collaboration between projects from Costa Rica and Ireland. I don't know if you can see further, yes, collaboration between both countries.
I'm not sure, definitely I don't have any collaborations with Costa Rica at the moment. I'm not sure, maybe Sean, from the BiOrbic could, explore the possibilities, but we are not sure. Yeah, but we don't have any at the moment. Yeah, don't have any at the moment.
Okay, perfect. And from Costa Rica side, does someone would like to? Okay, Mr. Rojas, please.
Thank you. Well, we don't have a collaboration at the moment with any part in Ireland, but of course we like. But I would like to come back to the presentation of Dr. Babu about the membranes. So what is the main process that you use to make your membranes, or to escalate a little bit the production to make it more not industrial, but to have a certain amount of membranes to use for different bio applications? What is the main process for you?
Yeah, thank you, Oscar. Yeah, we use both solvent casting, okay, and thermal induced phase separation, and also electrospinning. So I would like to say, it means Ireland has Merck Millipore based in Ireland. So we worked with Merck for the last 15 years as a collaborative projects in developing the new membranes for various applications. So we explore different methods, but in my lab, we have electrospinning, and definitely we explored this technology on a pilot scale to produce maybe hundreds of meters of membrane based on electrospinning. And also the solvent casting method. In our lab, we can produce 2 to 3 meters solvent casting rig. We have, so yeah, we explore different techniques for sure. Yeah, definitely, you know, I'm happy to talk more details.
Because we have some interesting materials. So Guillermo was showing here the cellulose, and also he mentioned about chitosan, and also we are exploring in the lab the use of collagen, for example. But maybe the main process that we are using is just solvent casting. But of course, would be very interesting to produce our membranes by using your technology. I don't know if this is possible to establish kind of visit to your lab, or I don't know.
Yeah, sure. I think definitely on electrospinning technology, that is one of the area we explored in recent years. And there is a patent published already in that technology along with Merck. Yeah, so definitely we explored using electrospinning as a technology to create industrial scale membranes, for medical applications. So if you want, I can share those details. It is available publicly, that information. We can explore. That's one of the area we are pursuing at the moment, using renewable polymers to creating advanced applications.
Thank you.
Perfect. Thank you, Mr. Rojas, for your question. And do you have any more questions in regards to the presentations and also possible collaborations between both countries?
Maybe one more question.
Yes,
sorry,
please.
Yeah. This is for Tanya. So in the past, we tried to do some experiments with production of polyalkanoate, but our yield was not so good. So we don't get any high production of the polymer. So what is your production? What is your yield in the lab?
So we have process developed when we're using feedstocks that are rich with fatty acids. We get about 50-60% of PHA within a cell, and we're able to drive cell density up to 110-120 grams per liter. So approximately half of that would be PHA. And then I did mention, like PHA has a regulatory role in metabolism overall. So what we're trying to do is override that regulation. And we have seen that by, removing certain obstacles in metabolic pathways, we can further increase the yield per cell, which then we're now testing in a larger scale fermentation. So it's about, let's say 60 grams per liter if we use fatty acid rich feedstock, oil-based feedstock.
Okay, thank you. So
Thank
maybe
you.
we can talk.
I'm sorry.
Colleagues, and maybe one of my colleagues can be very interested of to continue the project, and maybe we can be in touch in the future.
Absolutely, happy to chat. You will have my contact details. We can talk.
Thank you.
Thank you, Mr. Rojas and Dr. Naranzik. Okay, thank you everyone for having your time to share your presentation, your work that you're doing in Ireland and Costa Rica, and also thanks for all the participants for your time of being here with us. And we hope this session, hopefully it can create future collaboration between both countries, and also start hopefully two new projects between BiOrbic, and also the Biomaterials Hub. And we would like to invite you to the main section. We will move in back to the main session, right, for an open discussion, and then followed by the closing the webinar session. Thank you so much for your time, and yes, thank you all.
Thank you.
I hope everyone had a great session today. At least with the bioprocessing, there was a lot of interesting talks. There's a lot of relevant and potential opportunities for collaboration. Now, I just wanted to spend a short moment to maybe get some feedback, maybe have some open discussions about specific areas of collaboration. We have all or most researchers back in this main room. Should there be any open general questions, comments, or thoughts, this is the time to do so. We'd love to hear your feedback on this first and inaugural encounter session with Ireland. Do you see value? Do you see potential opportunities? Do you have an idea of where we want to take this? Open to any questions or comments. Please raise your hand. Okay, I've got one. So Anna.
Hi. I cannot start my video though.
Oh, okay, one sec. Yeah, I think you should be able to now.
Okay. No, first of all, thank you very much for the presentations. I think they were like wonderful and inspiring. I just wanted to know if you, Adim, from the Hub Biomaterials, you have like next steps, like how we get in touch with the researchers and start a conversation to future projects, joint projects or things like that?
So from our side, we will be sharing information of all the presenters, all the speakers, so you'll have the opportunity to get in touch directly. And as for the next step, the idea was to, well, of course, share the presentations as well, share the recordings with everyone, so you can assess the other sessions as well. We're hoping that we could, once we identify potential collaborations, we start talking about potential funding opportunities and how can we look out for specific European funds that allow for collaboration with Costa Rica. Now, maybe, well, what we've seen is Costa Rica is eligible as a third country for EU funding, which makes potential collaborations very interesting and accessible to Costa Rican researchers, which is one of the reasons why we wanted to push forward this session, because we know that the opportunity for funding access is possible. Now, I have a question from Professor Tamayo. I don't know if you want to ask your question, or should I read out your question? You're on mute.
Yeah. Okay. Thanks, Adim. Well, the issue here, what I'm hearing is there is a lot of resources from the academia that are willing to add value in their research, and the experiences that we have heard from Ireland and in particularly those are very, very nice examples. But the elephant in the room are two things: how you can actually do a mutual beneficial contractual agreement between industry and academia, and how long it will take. I mean, in our experience, this is something that takes something around a year or even more. And this is actually not very good for researchers that are looking into how they can get some funding for this. I'm happy to hear that you are thinking of European funds. We have been successful sometimes, but it depends on, in our experience, how well positioned is the European partner to actually access this kind of funding. The other thing, the elephant in the room is some that I will add to this elephant that I have placed already, is that we have to, if we want to raise funding for this, not only from organizations like the European Union, but also from the industry, we will have to demonstrate that this has some value to them, and the value to them is not social, it's economic. I mean, they are the private sector, as a matter of fact, and having in hand what I was asking. I mean, if you invest this dollar and over 2 years in this research, you will get a technology or a product that will give you $2 from each dollar that you have invested. That is something very important. The number of employees that you have increased in your industry, given this technology that I'm transferring, is also very important for actually providing examples that are successful in terms of investment and in this join of academia and industry. That's the two elephants in the room that I would like to address and see who can help us in answering this.
So I believe Sean has volunteered to answer some of that.
Thanks. Yeah. So I suppose, yeah, just on the return on investment, we had a consultancy agency. So they showed that for every €1 that our industry partners invested, it generated €4. Now that's in phase 1. Typically, it's higher in phase 2 of research in Ireland. So, you know, we do focus on collaborative projects with industry. So we receive, as Kevin mentioned, we were an Irish National Bioeconomy Research Centre. We receive funding from the Irish government through Science Foundation Ireland. So we can do part of that remit and scope of what we can do in terms of research. We can do research with companies that they don't have to be Irish, as long as we can show that there's a benefit to Ireland and the Irish economy. Then we can, for example, work with, let's just say, medical device companies in Costa Rica that want to do research. So it's collaborative in nature. So it can't be, we do get a lot of companies coming to us and saying, oh, we'd love to see if we're carbon neutral. Now, that doesn't affect the bottom line right now, but it's a reputational risk to those companies. And there is that ESG component that it's coming down the tracks, and it's coming very quickly, and the pressure is increasing to be more environmentally sustainable, and the reporting is going to become more and more strict. So something I say to companies is the regulations are getting tighter, and they're more than likely not going to get any looser to 2030. So, you know, I fully accept, you know, there is that urgent need, like it has to provide value to industry economically. But we're lucky that the companies that we do work with tend to have a, you know, maybe a five-year term that they want to be more sustainable. And they realize that if I'm more sustainable, it'll have less costs as well as better reputation. We'll be able to get better talent coming in. So, yeah, we can, really the point I want to get across is, as a research center, we can work with industry from countries that are outside of Ireland, provided we can show that there is benefit to Ireland, whether that's in terms of exports, imports, and we have a lot of multinationals in Ireland, so we're kind of used to doing that.
And maybe you could touch upon, I think, Professor Tamayo's first question, which is, what's the contractual engagement like when you work with these industries?
Yeah, so typically we do collaborative research projects as opposed to contract research, and we can provide up to 50% funding. So while we're a research center, we also do have funds that we can allocate to our research projects. So we can double the size of a project, industry give an amount, and we can match that funding. So it's collaborative in nature. So typically the research question would be around, let's say, for example, instead of, can you tell us if we're carbon neutral or not, it'd be more, how can we become more sustainable? How can we get to carbon neutral? So it's Yeah, I hope I've described that. It's not binary. You know, the answer usually isn't a yes or no answer. It's usually more collaborative, that neither party knows the answer, but also we can't do the research without industry's involvement, and vice versa. They can't get to the answer without engaging with the research centre.
Yeah, excellent. Thank you, Sean. Got a question from CINDE.
Thank you. More than a question, is because you asked about if we see some points of collaboration. So I would like to summarize something that they were talking during the presentations. Well, I see the opportunity to strengthen the validation, product validation that we need with them, because I see that the biological strengths are really deep and developed. So I think that we have there a really nice opportunity for collaboration. And the other thing is that we see an opportunity to use the biological cellulose process as a complement of our proposal. So maybe we could work in that line too. Of course, that we could add in the research. Sorry that I don't see here. David O'Connell, I think that was the presentation. I see that maybe we could have some collaboration using our nanoparticles and nanohydroxyapatite particles, just to see the biological response that they have with the cells that they are producing right now. And I think that was from the first presentation that they show about the packaging, because here in Costa Rica, it would be really nice to produce our packaging for food packaging using our biomass as well. We have been done some work using cellulose acetate from our residues. But of course that for the layers and the functionality, we have a really work to do. And the last thing I would like to ask them, in a timeline, what did you expect working with Costa Rica, like in a funding? Have you see some opportunities? That is my question. Thank you.
So with regards to your last point, the idea was to identify potential collaboration links first, and then we will explore with BiOrbic where that funding potential lies. Christine is here and she does a lot of the assessment on the EU funding and the national funding in Ireland and in Europe. So the idea is to identify collaboration links first and then see which funding mechanism could apply to that collaborative opportunity. Either if it's part of a larger consortium or if it's just a bilateral research partnership. We'll have to identify what the funding mechanism could be for that collaboration.
Just a comment, sorry. So in that case, I think that for that, I would like to propose that you could include the graduate student program just to develop the research that we have been mentioning the past 2 months. Thank you.
Yeah, excellent. I believe we had a hand up from Derek, but it's gone down.
Yes, yeah. Well, you made some of the points I was going to make at him. I was just going to add further to respond to, well, first Professor Tamayo's comments or question, just around, well, 2 things. One, so being positioned for EU funding. So obviously Ireland is part of the European Union, and we're heavily involved in EU funding programs. We've been very successful in Ireland, and indeed more specifically in BiOrbic in attracting and securing Horizon EU funding. But then look, from our perspective, we're also interested in other funding outside of EU funding as well. So that's part of the reason that maybe we haven't necessarily identified that yet, but that's part of the discussions we're having with Costa Rica to see if there may be others. So it's kind of working together to see where there are funding opportunities. And then with industry, with your comment about industry, yes, we have faced the exact same challenges you have, and it is extremely, it can be difficult to get industry aligned with the type of research that we are doing, and it takes a lot of discussions, as Sean has outlined. We have been talking to CINDE and Adim about potentially a further session where we could share some learnings with each other on that. We have in Ireland, we set up a national knowledge transfers group or organization. We have established and we use in BiOrbic for all our industry projects, and we've developed template contracts for industry because it just cuts out a lot of the negotiation, and it manages expectations, because I think that's the key thing. Obviously, what we have found certainly, and we've quite a lot of industry collaborative projects, managing expectations for industry, but then also for researchers, so that there's a recognition from the start on what the objectives are for both, and then the discussion is around establishing common ground where both sets of objectives or common objectives can be agreed. It is challenging, but we in Ireland have spent a long time, I think. Now we're far from perfect, there's no easy solution, but we would hope as part of this engagement, and today being the first step, to share some of that, and then also to learn from your perspective as well on how we can best manage that. So that's what I wanted to say, Adim.
All right, excellent. We have one last question. So Anna Margarita.
Yes, I would like to ask which kind of joint projects are able to apply? For example, in some way, like bilateral projects?
So I believe Christine would probably be better fit to answer this question from a funding standpoint.
Yeah, so it's just that Costa Rica are eligible for European funding. So I guess what we do would be we just look at the work programs and see where we can find mutual interest. So obviously you have to address every point of the call. So it would be, BiOrbic addressing a research in BiOrbic addressing a certain point, and then potentially a research in Costa Rica. So it really depends. There's like a vast array of European calls, and most of them would be consortium based. So it probably wouldn't be a bilateral as such, Irish Costa Rica. It would probably be more a consortium, but we do have a lot of connections within Europe, and as Derek has said, we have been involved in many European projects, so we would have those connections in other parts of Europe, so that shouldn't be an issue. But again, like also what Derek said, like we have the European funding, but we would be, happy to explore other options that we are not so much aware of, that potentially researchers in Costa Rica would be more aware of. So it's quite open, I guess, at the moment.
Okay, thank you.
All right, great. So with that said, thank you all for your inputs and your comments and questions. I'd like to close the session by saying, firstly, thank you all for joining us today. This is hopefully the first of many where we can identify new collaborative opportunities between the two entities, countries, and various institutions. I do see a lot of opportunities just from the surface level of the science and the research potential. And I'm hoping that the researchers and the speakers and presenters and even the audience see other identifiable opportunities. And of course, we'll be sharing information of all the speakers, so you'll be able to get in touch. And of course, if you do identify some sort of opportunity, feel free to message myself, anyone at CINDE, anyone at BiOrbic, and then we could start talking about how we could bring this to fruition. Yeah, that's all I had to say. Thank you very much. I don't know if Derek from BiOrbic had any closing points.
Yes, sure, yeah. So just for anyone who doesn't know me, so I'm Derek. I'm the executive director at BiOrbic. And yeah, so we've come to the end of the session today, which is the first Costa Rica Ireland Bio Encounter. So I'd like to thank all of my colleagues, my own colleagues from BiOrbic, and everybody from Costa Rica for joining. It was probably a bit easier for us in Ireland, as I think they started at 2:30 p.m. whereas you had to start at 8:30. So we appreciate that and we thank you. Just to say, for us in BiOrbic, collaboration is a core value of the centre, and we recognise that the challenges that we are addressing, in particular, I guess, around climate, biodiversity challenges, and then including biotechnology and others, need as many experts and skill sets and perspectives working together if we're to kind of address these. And then this is, of course, also relevant if we're to realise the vision that Kevin set out earlier to establish a vibrant, sustainable circular bioeconomy here in Ireland, in Costa Rica, and indeed globally. And this is why we were excited in BiOrbic to connect initially with CINDE and the Biomaterials Hub, and now to meet all of you here today. I think we're both relatively small countries. We have different climates, we have different biomass, I think, but we're both looking to achieve many of the same things. And we see today really as a first step in establishing a strong partnership where two countries can mutually benefit by working together to achieve our common bioeconomy goals, working, I guess, through research and then targeting funding, which we touched on. But I think today is just a first step, and we really wanted to, and we talked to Adim about this, really kind of, it's on Zoom, obviously, but it's nice to actually have a conversation and a discussion to kind of get things, get the ball rolling. And we had really interesting discussions, I think, especially in the various different groups. And it was, from our perspective in BiOrbic, great to hear some of the excellent research that's happening and see some of the facilities in Costa Rica. And so we will continue in BiOrbic to work with CINDE and the Materials Hub. And we've discussed, I think, Adim, you're going to be sharing we'll be sharing the recording and the presentations, and encourage you as researchers as well to, I guess, engage bilaterally with the context that we've seen. If there's people that you've connected with or research that you think is interesting or interested in learning more, then connect directly or else via Adim on the Costa Rica side or ourselves in BiOrbic. And then just finally to thank Adim and Carola and Gloriana and I guess Jonathan for organising this on the Costa Rica side, and particularly looking after all the Zoom things, and Chrissy on BiOrbic side. And that's it, Adim. So I'll hand back to you. I don't know if there's a formal closer, but just to thank everybody again.
Yeah, thank you all. Have a great evening, Ireland. Have a great day, Costa Rica. I put my LinkedIn and email address in the chat, so if anyone wants to save that, get in touch with me, feel free to do so. And I look forward to hearing any potential next steps from the research or bilateral opportunities. And we'll keep you posted about the next, let's say, webinar session that BiOrbic and CINDE will be working on.
Thank you.
Thank you very much.
Thanks, everyone.
Thank you. Have a good night.
Thanks, everyone.
Bye.
Bye.
Thank you. Bye.
Bye. Thank you.
Thank you. Bye.